Back, everybody. So, great moderation and emceeing from Anastasia. Thank you so much. We are now in the final stretch, everyone. Thank you for sticking with us for so long today. Our last speaker of the day, talking about observability in DevOps from MoneyU. Please welcome Dipro Chatterjee. Deep, great to see you. Thanks for being with us.
Thank you so much.
Thank you so much.
Am I audible now?
Am I audible now?
Absolutely, sir.
Awesome.
Yes. So
Awesome.
I will leave the floor to you, and I'll come back at the end of your presentation to wrap things up. So the next 40 minutes are yours, sir.
Thank you so much.
Thank you so much.
So hello everyone.
I'm Dipro Chatterjee,
and thank you for
staying so long. And this is the final talk. And I want to share with you my passion about observability and why I care about it, and how I would idealize the ideal world where we would do observability. And I'm very keen to hear your constructive feedback on this, what your experiences are later on in the chat room, so we can talk about it more closely. But this talk is really focused on AWS serverless workloads. That's mostly my experience so far. And I'm going to really focus on how you can build an SLO document, how you can come up with SLIs, and how to really measure quantitatively how the system behaves. So this talk, key takeaways would be that. Before I start with everything, let's introduce myself and be polite. So I'm Dipro Chatterjee. I work for MoneyU. It's a fully digital bank from ABN AMRO. I started with them a few months ago. It's my fourth month. Before this, I was working with DAZN. It's a sports streaming company, and these are the two companies I've worked with where I have built and maintained critical production workloads on AWS, both serverless as well as not serverless. And I feel I'm very lucky to be part of this native cloud revolution. Why am I doing this talk, right? So one important aspect is that for me to learn something really well, I would want to teach it and share how I feel, and that helps me learn more. And that's why I do like to do public talks. And the second part, why I chose this topic, is because I feel in life and in software engineering, observability is really important to be able to constantly improve. And this is an aspect that I personally or my teammates, we have often overlooked, and later on it has blown up in the face, and we have come back and we have improved it. And that's why I want to share my learnings and the process to improving that. So if you are a junior DevOps engineer or even a senior who wants to go back to the basics and wants to reevaluate how to do observability, or just get a refresher, or if you want to get introduced to this really ambiguous terms, SLIs, SLOs, and you want to know how to get started, then this is a great talk for you. And if you really care about DevOps and SRE, then this is a great place. If you care about improving your software, and if you really want to know how to be in control of your system's performance and your customers' happiness, this is a great talk for you. So DevOps, right? This is a very catchy word. It's a DevOps track. So I felt that it's good to just not assume that you already know DevOps, or even if you know, because it's often used as a job title, right? Even I say that I'm a DevOps engineer. Sure thing. I cannot go back now I can. Are you able to see my screen now? Does this work? Hello? Okay, awesome. So to get back to the basics, right? When I started off, it would usually be that you develop something, deploy it to lower environments, and then you ship it off and you hand it over to the operations team. And thankfully, that's long gone, right? And we are one team that takes care of development and across the environments. We take it to production and post-production, and because of containerization and serverless, it's as production near as possible. And that's what DevOps really means to me, because it's one team where we don't separate responsibilities, and we plan the operational responsibilities right from the very beginning when we are designing the architecture. It's pretty similar to how test-driven design came. Now it's operational driven design for me. And it's important that we keep iterating over this. It's not something that is set in stone at the very beginning and that SLO document stays forever. It starts off with a very loose definition of thresholds, what's the definition of good, and then it keeps evolving over the period of time, what's the definition of better. What's more what I feel more passionate about is the word SRE, because it's something that I've been following from Google for some time, and they have this very famous book, the SRE book. And for me, site reliability is essential to building stuff in production. And the reason is, you want to build software to keep it up and running, right? And if you want to be able to measure that, there has to be a certain metric: availability, uptime, error rate, and we need to be able to defend against those standards, which is our SLO. We need to be able to quantitatively measure the system, which is where SLIs come, and we need to have constant and effective monitoring of that. If something goes wrong, we need to be paged, so we need to have an error budget, and we need to make sure that the frequency of being paged is also something reasonable for the health of an SRE. So it makes sure that we have a reasonable policy for that. And then, of course, you need a tracing tool, you need a logging tool, you need centralized logging, aggregated logging, and you need to be able to do the root cause analysis of an incident. And, of course, there has to be the proper delegation of an incident in a proper incident management framework. And you need to be able to correlate the dashboards and the logs and the traces, and then come up with the root cause analysis so that it doesn't happen again in the postmortem. And of course, once you've been able to investigate, you're also able to bring the system back in the error budget. But here in between, there is a conversation that goes on where you have to choose between making a short-term fix, a hot fix, or you have to roll back to a previous release that worked fine, so that the customers are not affected. And then in the sprints that follow, you have to then have a conversation with your product owner. Do you want to really invest in this tech debt, or do you want to accept and you want to improve, or do you just want to cancel your error budget for some time? You just want to suppress your SLOs and just go on investigating, because the error budget will just blow up your alarms. So we talked about a lot of stuff that measures and makes us act upon the system behavior. And that means that we need to be able to make it observable. It's important that we are able to make it easy for human beings to understand at any given point how your distributed systems are behaving. And because of the distributed systems nature, it's very easy for a mesh to become a mess. And the three pillars for me in that, and that has always been logging. Logging has always been there. Otherwise, you wouldn't be able to debug. Metrics and tracing are things that really come with public cloud providers. That's something that AWS gives you out of the box. You have CloudWatch metrics, you have CloudWatch alarms, you have X-ray, and if you enable these features for your serverless workloads, you have it out of the box. And if you really care about these things, and whether you're a DevOps engineer or an IT management trying to drive the SRE culture, or you're a product owner who really wants to remove the noise from usage analytics, and you really want to make sure that your customers, both internal and external, because of course you have several teams who are collaborating together. So it's very important that we are able to manage expectations at a team level or product level. And we really are able to measure this. So this is very important, that in your companies, you really take observability seriously, so that you're able to hold yourself accountable on these dashboards. And this is a question that's obviously rhetorical, right? When shall I bother about observability? Is it after we go to production? Is it during shipping? Is it when we are designing it? Or is it during development? Or is it never? The answer is all the time. It cannot be at one phase of software lifecycle that you care about it, because it has to be an evolving dialogue. Why is it important? Now, you might think that I don't really need to know this. If I have logging, I may not need metrics. If I'm really aware of how the code works, then I don't need tracing. But the same thing goes for readability. Then you don't need to write well-readable code because you know how the code works. So then you don't need to have even logging. You can just see an error and you can troubleshoot that. So it's not a good reason to not invest time for a DevOps team in observability. So you really need to know how the system behaves at a glance. And to keep customers happy, it's a catchphrase, right? But you need to be able to hold yourself accountable for how your system behaves. And the easier it is to monitor and defend against that SLO if you have a really good dashboard. But at the outset, it's very important for us to accept that there will be incidents. There will be outages. And often it happens that because we get so passionate and overwhelmed by these metrics, we want to hit against such high standards where we say 100% uptime is what we are looking for. But if you really measure, if you really want to hit 100% uptime, that would mean that you don't release any new changes. The more you scale up, the more number of errors you will get and the more number of alarms you will get. So that means that you really have to keep your expectations within your error budget, and you have to accept realistically what's a loose threshold to start with, and then tighten it as you go further. And then after a considerable amount of time, you've probably settled on a sweet spot. And this is also what will help you to do the root cause analysis of what has happened, why it has happened so that it doesn't happen again. And then what is the action point? Do you roll back or do you make a hot fix or do you just go ahead and spend a sprint to make sure that this is properly invested upon, the tech debt is removed? So it does help us to be iterative and agile. So over a period of time, it's not something that we can improve in just one sprint or two sprints. It happens over a period of a few sprints. Now this talk, over the period of this talk, you will see that I'm taking a lot of references that are heavily drawn from the SRE book from Google and the SRE workbook, which is a sequel to that. And of course, I would really recommend to visit the blogs that my former colleague Jan had written on his website, The Burning Monk. And last but not the least, the operational excellence white papers from AWS. They are a great way to start. If you start reading the SRE book, you will know about the golden signals, right? When you are trying to measure metrics for system behavior, you would know that there are a few golden signals that you absolutely have to measure. So the first thing that comes to my mind is latency. In my last job, when I was working with DAZN, it was very important, right, for us to be able to give a product to people that they can use and they have a very low latency. Otherwise, they wouldn't come back to watch sports. In my current job, it's the same. If I'm trying to make a payment and I have to wait for 4 or 5 seconds, it's not a great experience for me because we are a digital bank and we want to give a solid, reliable experience to our customers. But then how do we really measure latency, right? There are so many mathematical functions. In the next few slides, we will really focus on this one metric, latency, and what are the different ways of measuring latency and when you should measure what. Then there is traffic. So that means the number of requests that you have in your product and the burst metrics. So like it could be that there is a big sale going on and then you have a big burst of customers coming in and then there's a huge spike. Or it could be on we are often very drawn to looking at the mean or the average of the number of requests, but it's also often valuable to have a histogram where you have over a period of time, you have a graph and you see how many requests you had. And then you have errors, which is to me the most important metric. And you have different ways of measuring errors. So you have error rates, you have number of errors. You can classify these errors as coming from bad inputs. So it could be 4xx or it could be something that happens on the network level. So you might want to measure your 504s, or you might want to measure how many 5xx you had. And of course, if you're using compute, you might want to also focus on saturation, so memory management, CPU utilization rates over a period of time, or the max. And it's very important that we ruthlessly eliminate as many metrics as we can over a period of time, because if we don't eliminate metrics, that might mean that we are lost in a sea of metrics over these 4 broad pillars, and we have so much noise that in an incident at 3 a.m., you might not want to look at these and you just feel lost when you have to troubleshoot an incident. So to help us really get hands-on on this, I came up with a sample product. Because it's the Corona time right now, I'm really finding it hard to make sure that my kitchen is stacked up with all the groceries I need. So I'm building a personal project which is supposed to have a track on what groceries I have at any given point. And it's a very simple REST API that uses API Gateway, Lambda, and DynamoDB. It's a post API, so you're going to insert a contract according to a contract agreed upon payload, and that's going to be persisted. And I'm going to create an inventory, and I'm going to measure their expiry date and how much I have. So then now we are going to talk together what SLIs we would want to have to measure that a customer who would be using it would be happy. And this customer could be the front-end application. It could be another API that is integrating with this API so that they can get usage metrics. And it could be an end user. And we also want to measure the system state so we know how available the application is. And then we will create the SLO document on these SLIs, and we have an intuitive threshold so we don't just come up with an abnormal limit. And we create the error budget and alerting policy. There is a thing that has to be mentioned here that I cannot live do it because there's a lag between your actual API call and CloudWatch metrics being emitted. So that means that if I have to test now and I show you metrics, it would take a few minutes lag. So I've already had a test where I can show you alarms being thrown and metrics being emitted. So this is the very simple architecture. You have an API gateway, you make a post on the endpoint groceries, and it triggers a Lambda function post groceries, and that will persist on the groceries Dynamo table. And these are the SLIs that I've already pre-prepared for this talk. The error rate, the P99 latency, which is the 99%, which is the latency of 99% of requests. Error rate can be defined as the number of errors divided by the total number of requests. Tail latency is trying to focus on the number of requests that were, or the requests that had the maximum latency. So it's often misleading if we use the average, that we are lost in a figure that doesn't tell us much about the requests that were really slow. So that's the tail end of the request, and that's what we really want to focus on. And then we also have a histogram so that we can see the latency distribution. So it might be that when there is a big peak, that there is a lot of tail requests, but then over the period of time, it gradually levels up. And then you have the availability rate, which is the total number of successful requests divided by the number of requests. And then you have logs and you have traces inbuilt. So these are the ways that we would measure the availability of the sample product. And before I move on to that, let's go on to the code base. Are you able to see my screen? If you could give me some feedback, then I have a confirmation that I'm sharing the VS Code. I guess that's a yes. I'll go ahead. So this is, I'm building this project with serverless YAML, and so I have log level set, I have a custom domain name set, I have some environment variable set for the Lambda function. It's using the Node.js 12 environment runtime, and this is the definition of the Lambda function. I'm using TypeScript, so that's why you have the JavaScript from output. And this is the trigger that will trigger the Lambda function. We are using a few plugins here, the log retention for being able to do this, the log retention in days, pseudo parameters so that I can dynamically parameterize account IDs in the YAML, and deployment ID, IAM roles for IAM role statements, and domain manager to create a custom domain. And here you can see I have the dashboard built in. So this is operations as code. I'm sure in the previous talk that you had on CDK, you know you can do this in a much more user-friendly way than YAML. What I've done here is I've prepared a dashboard, which is this dashboard over here, and I have exported the source code from here. And yeah, as you can see here, you can export the source code. And what you can do is you can include it in your CloudFormation or serverless YAML stack and build the first dashboard on your test environment and then promote it consistently across the higher environment so that you have the same dashboard. This of course helps if you have an incident, you can replay that in your lower environment and troubleshoot the same way on your lower environment dashboard the way you would on production. So this is in a nutshell the DynamoDB table that I have built, and this is the schema of the DynamoDB table, and this is the CloudWatch dashboard, Lambda function, and that's the API gateway that is inbuilt by serverless. And just going through the JavaScript code that I have inbuilt for the Lambda function. So this is instantiating a client to communicate with document client of DynamoDB. It is going to check if the payload is empty or if the table name is configured correctly. Then it's going to throw errors immediately. And then I have built a contract based on a library called IOTS, which makes a codec out of your contract and real-time it decodes. And it's something I recently learned from one of my great colleagues at MoneyU, and I would really recommend this library. It's a great way to have dynamic runtime guards, because TypeScript gives you a static compile time type guard, but at runtime you don't have type safety, which is given out of the box by IOTS. And if it is, if the payload is not in the format or not validating the contract, then we throw a bad request. And if it goes ahead, then I construct the Dynamo input and I throw an error if that doesn't work out. So this could be because the throughput capacity is exceeded, or if the item is larger than the item that Dynamo allows you, so it exceeds the max size, or there is a network timeout between the Lambda resource and DynamoDB. And that could often be that there is a timeout. And this is a middleware that I'm using to report these errors. So in a nutshell, that's the code base. So I'm going to go ahead on Postman and I'm going to make a request. As you can see, it took 913 milliseconds, so that's quite high. It's almost a second to do that. I'm going to make a few more requests, and it's considerably shorter now. And I'm going to go ahead in the dashboard and I'm going to refresh the screen. And as you can see, the 4xx error rate, it's not an error rate anymore. Sorry, it is error rate because I'm taking the statistic of average. And the total number of requests is 4, so I'm taking a sum here. And if I want to edit this, it might be important that you want to know the total number of 4xx, which is still 0. But the reason why you don't want that is because you want the ratio of 4xx errors to the total number of requests, which is what average would do. So that's why this is, so both for 4xx and 5xx, I have average set. For integration latency, I have the max, so that's the tail, and that is 763 milliseconds. And for latency, I have P99, so that gives you an idea of 99% of your requests, how long it takes. And that's also 763 milliseconds, and this is the total number of requests. If I refresh the screen, you can also see the Lambda metrics here. These are the metrics that AWS gives you out of the box. These are not custom metrics, so they come to you for free. You can see there are no errors so far. There are total invocations of 8. There are no throttles yet, so the function hasn't been throttled for any reason, and that's the average duration of the Lambda function. And unreserved concurrency and all that. This could be useful, but of course, over the period of time when this dashboard matures, you would want to eliminate these metrics that don't really make sense. You can see that the tail duration of Lambda is also reported here. It's 126 milliseconds. So this gives you an idea that the average is 65, but the slowest was 126. And if we make a few more requests, you can also probably see the metrics going on here. So if I make this, hang on, 5 minutes, maybe a day. Yeah, I think that's probably easier to visualize this. So you can see that it started off around 683, but now it has considerably lowered over more requests. So the first request took some time. And now to simulate a few errors so that we see how the errors are going to show up, I'm going to send some bad requests. Right? And there would be some lag here. It won't show up immediately, but in some time you would see that change to 4. So I'll let that be, and in the meantime I'll move on to my slide. So let's go back to defining what's an SLI, right? An SLI is a service level indicator, and it's used to measure quantitatively and as accurately as possible the behavior and the state of the system. And we have already seen some sample SLI. So one is availability. This is something that we want to know, how available our systems are. So it's the ratio or the percentage of successful requests to total requests. It might be that your product is barely used, and then the total requests is low. So it might be something that you think of when you are trying to build this ratio, that you have at least a few sample requests on your product. Then you have a latency. Latency is, again, it's a very important metric, and you could have a graph or an histogram to, over a period of time, see how your latency is evolving. You could have the ratio of requests. So you could build a threshold that I want a latency of 500 milliseconds. That's my SLO. And I want to know the ratio of requests within that SLO divided by the total number of requests. So that could be a good availability metric as well. Another latency metric is P99, so that could be the percentage of requests. In here, in this case, it's 99. So that is also given to you for free by AWS. And you have the error rate, of course, that you saw. It was ratio of errors to total requests. Saturation, I don't have it yet because I don't find it necessary for this product, so I don't build it. Now, the cool part is, how do we measure these SLIs? Because you have different mathematical functions. You have mean or average, you have sum, you have histogram, you have ratio, you have percentiles, and you want to know which one to use when. So as I said earlier, that it could be that if we use average latency, you have no visibility on the number of requests that were really slow, or why they were slow, and when these requests happened. So that's probably why you would want to have a histogram where you can see, or you can see the number of tail requests. Success ratio does not really say much about the error requests, so that's why you want the ratio of errors. But again, in these errors, you want to classify them as 4xx or 5xx, or the number of errors you really care about. It could be a dependent downstream system is out, and you want to log that as a custom metric, that these are the errors that come from the dependent system being out of order. And these are the total number of errors, so you can easily delegate that responsibility to another team or a third-party vendor. And the granularity of the time also matters in the histogram. So how exponentially your granularity on your x-axis grows is very important, because if you're talking about latency, it might be that we don't want to measure latency over 100 to 300 milliseconds, because that's too low for your system. You might want to measure it 100 to 500 milliseconds, and then 500 to 1500 milliseconds. Or your system is really customer facing, and you want your latency to be 100 to 200 milliseconds, or 0 to 10 milliseconds, depending on what your need is. So the granularity of time really matters. Granularity of time also matters in the time series. So it might be that your CPU utilization really doesn't matter over 30 seconds. You want to look at it over a period of 1 or 5 minutes to really get a proper idea of your workload. It really depends on how your compute is, on the load is, and the hierarchical metrics, as I just mentioned. If you have a lot of third-party systems and your availability depends on their availability, it's definitely a thing to think of, that you have distributed systems and you have hierarchical metrics where you say, my system is X and the third-party system is Y, and you want to increment the number of X.Y errors or the number of X.Y successes. so that you can measure your availability versus theirs. We were looking at CloudWatch. So there are a few metrics that come for free. So for example, the metrics from Lambda, Dynamo, API Gateway, a lot of these metrics come for free. What doesn't come for free is the availability rate. So you don't know out of the box what's the number of successful requests divided by the number of requests. That would be something you have to build in yourself. And you can, of course, build alarms based on these thresholds, and that's when we come to SLOs. And let's talk about an SLO now. So before I go here, let me exit once more, and I expect an alarm to have gone now. As you can see, there is an alarm that has rung, and that is too many 4XX errors. And that's because, as you saw, I had 4 4XX errors, as you can see in the dashboard here. So this is the error rate, which is 33%. That's not great. If I go in here and I edit this and I make this sum, you will see that there is 5 4XX errors. And total is 15, so 33% sounds about right. That's your error rate. And my alarm rule was that if I have more than 3 4XX errors within 5 minutes, that's my SLO, then I want to be alarmed. So I have got an email already that I had too many 4XX errors. So I'm going to go back to my slide and talk about SLOs now, right? So an SLO is a service level objective that we commit ourselves to. And that typically could be that we have an SLI and we want to have a threshold that the SLI always has to be lower or greater than this threshold. And if we miss that threshold, if we miss that, then we miss our SLO. And there are 2 different ways to measure it. We have black box monitoring. So this could be things that are essential to the user, that are user or customer facing, that doesn't really look at saturation or latency of integrations. It just looks at the latency of the API. And then you have white box monitoring, where you look at memory management, you look at invocations, you look at several metrics that could be useful to understand why the black box metrics went wrong. The black box helps in deciding how often you want to be alarmed, because you don't want to be alarmed too often, and that means that we set meaningful thresholds, and the black box monitoring helps in that. White box will help you once you get alarmed. It can help you study the system state and correlate the incidents and logs and be able to come up with what went wrong. And then you define your error budget policy. So right now you saw that we got alarmed because there were too many 4XX requests. What could this mean? It could mean that there was a new release from the front end that broke the contract with the back end, and that's why this is breaking. Or the back end released a change that violated the contract with the front end, and that's why we have too many 4XX errors. And that means we need to have an error budget. If there is 1 4XX error, do I care? No. I only care when there are more than 3 4XX errors. And then I throw 1 alarm. However, there could be some errors that are business critical, and I want to throw an alarm on each one of these errors. So that's very custom made for, depends on the product, depends on the business. And this is decided by the DevOps team together with the product and the various other business stakeholders, who decide collectively what is a business critical error, what needs a human to be paged and needs immediate attention. And the stakeholders must agree together on these alerts and the frequency. And it also should, we should also keep in mind the health of the SRE that gets paged, because you might not want to get paged more than 3 times, because if you have already looked at 3 incidents in one given day, then you might want to take a rest of 1 day, and then somebody else comes and does it. So this has to be a policy that we have to look at as well. And then when you're defending this error budget, you might need to look at reasonable action. So what do we need to do in order to defend our SLOs? So if we are nearing consumption of the error budget, we might want to have a decision matrix that says if we are nearing it, we might want to roll back to a previous release so that we don't enter in deficit and we don't have customer impact. If we don't, if we have already compromised the error budget, then we might want to look at how many customers we have impacted, and that could be a reasonable action to take. If we think that it has too much impact and we can't really meet the customer agreements anymore, we might want to suspend our SLOs for some time, and we might invest in improving the system and then get back in the error budget again. So this could be several different actions, for example, in order to defend this error budget. And there has to be the trade-offs that needs to be considered. And then after every incident and post-mortem, you have to revisit it and evolve that. And an SLA is an improvement on this SLO, where you have a significant buffer between your SLO error budget and your SLA error budget, because not meeting your SLA might mean financial obligations to your customer or some kind of refunds that you have to do. And that is not the same as SLO, and that needs a lot more consideration from the business side of things. If you want to look at how availability is measured, you can go to this website, uptime.is, and it can give you what is a downtime if you have 3 nines or 4 nines or 5 nines. This is a website that tells you quite easily how to calculate. So with that, I come to the end of my slide, and I have a few takeaways for SRE engineers and what that might mean for you going forward. Is that you first need to protect your health. That's very important, right? It's very overwhelming to do this and be proud of your infrastructure and defend your systems. But if you are going to do this too often, that you're on call and you have to protect your systems or you have to troubleshoot, it might mean that you have a possible burnout. So you have to protect yourself against that. So have a good on-call rotation policy. You have to alert on a very reasonable alerting system and prevent spam alerts, because if you wake up and you see 15 alarms and you have to go through each one of them, it might mean that they are all coming from the same alarm. So you might want to prevent that. Reevaluate the SLO document periodically together with the product owner and see how you can loosen or tighten the threshold, what kind of labor you need to invest in order to meet those SLOs, and how you can improve your system and be aware of the system performance. And of course, negotiate an on-call agreement. This might be a bit uncomfortable for you, but it's important that you do negotiate this, because it does affect your personal life, and you have to take a lot of personal time and invest in this. So it make sure that you negotiate it well. For the product owner, what are the takeaways? Is that we need to come up with these OPEC metrics, and it's very ambiguous to come up with these kind of good SLIs that really tell you where your system is going with time. So it's important that we really start with a very loose and ambiguous system and accept that it's impossible to do it right the first time, but over a period of time revisit and think of how to make this better. Have a decision matrix ready. So you can never be fully prepared for an incident, but it's still handy to have a decision matrix where you know if the latency is down, how would you get it back? If the error rate is too high, what is a reasonable action to do? And this should be built in your muscle memory, so that you have some game days and you build it into your muscle memory, and you know what to do at 3 a.m. when this incident happens, for both the product owner and the next day when you have the discussion with the DevOps Scrum team, and you know how to navigate that discussion. Without being reactive, you can be proactive if you have that framework. And of course, protect the team's health over the product's health, but you also have to be mindful of the product's health. So of course, then you have to reevaluate your error budget periodically, because it might mean that your error budget is too tight or too loose, and you have to work with that creatively. So with that, I come to the end of this presentation, and that's my Twitter handle and my LinkedIn. So feel free to connect with me, and let's chat in the breakout room. And if you have any questions, I'm happy to answer and share my experiences. Thank you.